Okay, so 9.1 through 9.4, this section is all about area, which you should know quite a bit about area already. The main thing I want you to know, and that's what I went over in 9.1 quite a bit, is the fact why we label things square inches, square feet, square whatever. It's because how we measure area is in a specific way. So how we measure area. Okay. Somebody tell me, from what I talked about it, what are we actually doing when we're measuring area? Yes.
Seeing how many squares fit in it.
Yeah, seeing how many squares of a specific size fit within the shape. So we're looking for, it's the number of squares of a specific size, and that those sizes can be inches, centimeters, millimeters, yards, feet, miles, kilometers, all sorts of different measurements that we can put in, okay? And we're looking for how many squares that are that size that are inside. Now I can draw inches a lot better than I can draw a yard up here. A square yard is pretty long. Or pretty big. It's 3 feet by 3 feet by 3 feet, which is quite big. So when we're talking about square yards, that's a big area. So if I tell you something is 97 square yards, that's a pretty good size, okay? If I tell you it's 97 square inches, that's a lot different because an inch by an inch is a lot smaller. And when I'm looking at that, it's just going to be it's a lot smaller area. 97 square inches is a lot smaller than 97 square yards. Okay. So when we're looking at this, it's the number of the squares. Hence why our units in area are inches squared, centimeters squared, millimeters squared, yards squared, feet squared, miles squared, or kilometers squared. Now some people like to write it this way, square inches. This, I think, describes it more. It's just that I'm lazy, and a lot of mathematicians are lazy, and we don't want to write out the word square inches, so we write inches with a little 2 on it. But this just says I'm measuring it in squares that are an inch by an inch by an inch by an inch. Okay? They're 1 inch wide, 1 inch tall. Okay? And so that's really what this says, is we're measuring in this size of squares, okay? We don't have a measuring tool like a ruler or a yardstick that measures as squares. I mean, we have to have something that was, that many long, and we just don't have that. And so that's why we come up with formulas to find that area. Yes?
For like inches and feet, can we do like the 2 tick marks or 1 and then
square? Yes, you can do that. Yeah. A feet, another way of writing, let's see, inches is 2 and feet is 1. So 1 tick mark versus 2 tick marks. This is an inch and that's a foot if you use that. And you can put a little square on that. Okay, it's not quite as clear for a lot of people, but I'll take it because it is a legitimate measurement. Okay, so that's fine. Okay, so that's basically what the main point is I really want you to understand, why do we label area as square inches or square feet or feet squared? It's because we're actually using inches or squares to figure out how many are in there. That's the reason it's labeled that way. So that's why you can't label it feet. It's not just feet. It's not how many feet are in there. It's how many squares that are a foot by a foot by a foot. Okay, and so that's something that's good to know. Okay, where do we use area? What are some things we use area on? Yes. Rooms. A lot of rooms are measured by square feet. Okay. What else do we use? Yes.
House square footage.
House square footage. The total house square footage. The bigger the house, the more square footage you have. Yes.
Like a territory of land.
Yes, a territory of land. Okay. Now, I'm not going to go into acres right now because it's measured in a little bit different. Squares is not a foot squared or anything like that. But acres is a way, and an acre is a certain specific square size. So when you go and you see that this is 10 acres, that's because there's a certain specific size of square that fits in there 10 times. Okay, it's a certain measurement. Okay, we also use miles squared, specifically when we're talking about states. There's so many square miles in this state. So if you look up the size of Texas versus the size of Vermont, you'll see that there's a huge difference in the square footage of those feet, or square mileage of those cities, or gosh, I can't even say the right word, states. Okay, so there is a huge difference. And so that's how you can kind of compare things, because you're looking at the same things. Okay. We'll get into cubics later. So anyway, that's really the thing I really want you to understand is when we talk about square feet, or square miles or whatever, it's how many squares fit in there. Okay, it's not a magic thing. It's just if I were to take this many of those, that would be how many fit in there. Okay. We talked quickly in 9.2, I believe it was about the area of a rectangle or a square. This is the basic shape just because it's the easiest to draw, because rectangles and squares usually, you can fit squares in them nicely. Okay, so we talked about that, and we could figure out that one way to do it, especially if it's a nice round number, is that we could take the length times the width, and that would give us our area. Because if you cut it up into how many inches there are this way, cut it up into how many inches there are this way, you then have square inches inside of there. And so that gives us this number times this. Okay. They also use in our book B as the base and H as the height. So the area could be given to you as length times width. This is what we usually use with younger students, okay? And as you go, I will say it's used probably by 99% of people, but to keep it consistent with what we're going to do later, we talk about the base times the height. This is the base, and how we define the base is what it's basically sitting on, okay? Bases can change. Bases can change. It depends on how it's located or sitting. It's not a specific number, but it's the bottom side is what it really is, okay? The height, or sometimes they don't call it height, they call it altitude. It's the height or the altitude. And the reason why that's important is because when we measure heights or altitudes, we have to make it as a 90-degree angle. So this is really from the bottom, the base, how far does it go up? Straight up in a 90-degree angle. So it gives it a little bit more specific description there. So the height or altitude is at a 90-degree angle that's very easy when we're talking about these because we have a 90-degree angle that is the other side that goes up. That length or that height is that. Okay. So that's a different formula. Your book uses this. I don't know if they use both length, width, base, height, and base altitude, but I know they use some of those just to kind of get you to see that there's other ways of listing the same formulas. Okay. When you use a formula, what are the things you need to know?
Sorry. Just like that picture.
Hello? Yeah, that's me. Uh-huh. Oh. Okay. So, okay, let me get that out really fast. Just a minute. Guys, close your ears. I'm reading my credit card. You might steal it. Oh, I'm talking to my students. I'm sorry. Yeah. I'm talking to my students. I was telling them to be quiet. It's 5106 2406 5719 9535. Expiry or security code is 689. O227. And I'm wondering if there might be one thing. My address on this card, it's still 98604, but it's not the one that probably I put in there because I can't change it. It's 2215 Northwest 10th Avenue. Yeah, 10th, sorry about, no, it's not Avenue Street. 10th Street, Battleground. Yeah, 98604. Okay, thank you. Okay, goodbye. Sorry about that.
I can see 360.
Got my code all written down and everything?
Why'd you answer yes?
Okay. Now we're going into the next thing. Okay, so that was 9192 basically in a very quick summary. So now we're going to go into 93. 93, we are just talking about triangles. And what's kind of interesting about triangles, if we did an experiment on drawing a triangle, which I usually do this with pre-algebra kids, but if we take any triangle, so let's just start with one triangle. If you take any triangle, if you double it, you get a rectangle. Because we can cross across that line of symmetry there, fold it, and it gives us a rectangle. Okay? Hence, why the area of a triangle is the area of a rectangle divided by 2. Because it's just half of that rectangle, that's the size of the triangle. So we know the area definition, because what if it's not a perfect right triangle? Say it's some other type of triangle, so then we would say that it's base times, and I like to use height. I'm not sure if they're going to use height or altitude, but this gives you a better sense of height, because I like height. The reason I like height is because I know when I measure my height, and I know every time you guys measure your height, you do not slouch to get your height, because all of you want to be as tall as you can be. So what you do is you stand as straight as possible. So when I'm talking height here, it's the straightest possible measurement we can get. So if we have something like this, oops. Okay. If we look at this, here is our base, because it's the one on the bottom. It doesn't matter which base you choose, but sometimes the base is the easiest to be the bottom one that's on your paper. Okay, you can flip it around and get a different base. You'll still get the same answer. Okay, now what's kind of interesting about this is a right triangle then. Do you notice that again, I can take these two halves and put them here, and I have a rectangle, and I can find that, and this triangle is just half of that. So again, the formula works, but we have to know this height here, and sometimes that's tricky to find. But when we're looking at heights, remember that these are right angles. Okay. We usually know the length of these sides. Let's say I'll call this A and this B. We know that we can make them into right triangles to find just one of them into a right triangle to find that height. You're looking for one of the legs, not the hypotenuse, but you can find it that way. So again, it's always the height straight up and down with a 90-degree angle times the base divided by 2. And again, if you look at that, you can see why it's divided by 2. Okay, so let's look at one that's like this so that we can see how to calculate it if we don't know the distances. Okay, so we're going to go like this. I can't draw anything basically but an isosceles, but that's okay. Well, I guess that's not quite. So I'm going to say that this is 15. I'm making these up, so just believe me that I have no idea. And we'll make this 20. Okay? So, before I can find the area of this, I can go through and I can find this height right here. I just need to find the height. So I can choose one of these triangles. I don't have to do both. I can choose one of these triangles. So I'm going to choose the one on the right-hand side. And if I were to choose that one on the right-hand side, I guess we need to know something here. That's 20. We also need to know how much this is split into. We need to know these two parts, okay, to get that. So let's say that this one is 7 and this one is 13. So I have to know that. Okay. So that means I have this as 7, this as 11, and I'm looking for the height. Okay. I have a right triangle. Pythagorean's theorem works. Okay, so Pythagorean's theorem is going to be 7 squared plus h squared, because those are the two legs, and that equals 11 squared. So I get 49 plus h squared equals 121. H squared will equal 72, which, let's see, 64 is 8. So I'm going to say about 8.4. I'm going to guess. I know it's 8 something. Okay, so 8.4 is what I'm going to guess. So now we know the base of this triangle, which the base is 20. So my base equals 20. My height equals about 8.4. So I can find the area, which is 20 times 8.4 over 2, which is 84. Okay. And I don't know what it is, so if I don't give you units, you put units squared on it. That's usually how you do it. If it's not given units, like it doesn't say what those measurements are, you always put units squared, because it's not just a number. It's whatever unit we're looking at squared. Okay, whatever we measured this 15 in. Don't know what we measured this 15 in right now. It didn't tell me. So that way we don't know what the squared part are. Give you one other thing. Give it to you. Okay, I'm going to give it to you here. A different formula, which I think is kind of interesting. This was made, he was a Greek mathematician. He lived in the 1st century, and he derived a formula for the area of triangles based on their side lengths. This is called Heron's formula. Instead of using what we calculated based on the fact that a triangle is half of a rectangle, because that's really what this is, we use the formula that the area of a triangle is half of the area of the rectangle. Okay, that's what all this is based on. Okay. Heron's formula uses sides. So what it does, let's see, triangle with sides A, B, C, where else is half the triangle's perimeter. Therefore, you okay, so we're going to try it with, I don't have any idea if this triangle works, so we better try a different one. We're going to try a formula with 400, 600, and 1,000. Okay, so A is going to be 400, B is going to be 600, C is going to be 1,000. Okay. And it says Heron's formula is, we have to know what S is. S is the perimeter of the triangle. Okay, so in this case, what is my perimeter of this triangle?
2,000.
2,000, because it's 400 plus 600 plus 1,000. Okay, so S in this case is 200. I mean 2,000, sorry. The formula then for area, you can tell I don't use this very often, is the square root of S times S minus A times S minus B times S minus C. And that's what his formula comes out to be. Okay? So in this case, the square root is going to be 2,000 times 2,000 minus 400, which is 1,600. 2,000 minus 600, which is 1,400. And then 2,000 minus 1,000, which is 1,000. Okay. If we multiply all those together, somebody get their calculator out. multiply 2,000, 1,600, 1,400, 1,000, and then take the square root of that.
See what I mean? And what's
What?
it called? No,
Scientific notation,
yeah.
what is it?
4.48 times 10 to the 12.
Did
So
you
that'd
take
be-
the square root yet?
Not yet, so that'd be
Okay. Yeah, so go ahead.
12 zeros, right?
Yeah, it doesn't matter, take the square root now. You know how to take the square
Yeah.
root? Okay. What'd you get?
2,116,600.
2,000,000. What is it?
116,000.
Okay.
600.
Wait,
610.
million? Is this wouldn't be billion if this is
I said
thousands.
million.
Oh, million, okay, then go ahead. I'm sorry.
601.
Is that what you got?
Point.
Don't worry about that. Is that what you got?
Yeah, but I got 600. Let me count here. 221,166,010.
Huh,
That's
interesting.
what I got at 0.49.
I wonder if somebody put one less zero in.
I put 12 in, I think.
You should have 3, 4, 5, 6, 7, 8, 9.
10, 11.
No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There should only be 10.
It was times 10 to the 12th, though.
Yeah, that's because when you multiply 2 times 16
Oh,
times
yeah.
14, you get up higher.
Okay, so then I think that one is right.
Does that look right? Is that what you got still?
Yeah.
Okay. So I'm assuming that's right. That's his formula. Do you think that works in every triangle? Not sure, right? So let's try one that we know some information. I want you to calculate, and it's going to be a very easy calculation because I don't want it to be hard. I'm going to leave Heron's formula there. And here is just a basic right triangle. That's 5 by 12 by 13. I know that's an actual right triangle. That's a Pythagorean theorem or Pythagorean triple. So calculate the area using base times height divided by 2. And then calculate the area using Heron's formula. So let's see if you get the same thing. See how accurate this is. Looks like they've corrected my internet. I haven't gone out yet.
So it'd be 30, yeah, 30 square inches, or what is it?
What would
Is it inches?
unit squared. Okay.
Oh, yeah. So what'd you get? 30 times 25 times 18 times 17? Is that right? Is that what you got?
17
Yeah.
sounds
Okay.
right.
Let's see. $2,200. No. 221,500. And then the square root of it. Make sure I did that right. 39.
I need a calculator.
You can try doing it different. That's what I got. Oh, it shows. Yeah, because we should come out with 30.
Yeah, during us.
Or maybe we're supposed to get it wrong. We're supposed to get it right.
Did it get the same?
You got a different. You got a very different number, but I don't know how to calculate it. May have pressed more button. So we got, yes, 30.
Get something quite different? Get something quite different? The area is gonna be different.
Yeah.
Plus that. 21,500. I don't see anything that you did wrong.
What'd you get?
479 something. Yeah.
Are there negatives in this one?
No, shouldn't be,
Oh,
because it's
yeah,
the
it is.
perimeter.
How do you square root that?
Yeah, you definitely should get negative.
Oh, you know what? I lied to you guys. No wonder it's so off. It's half the perimeter.
Oh,
Ah,
Let me read these.
perimeter. That's funny. Okay.
So the previous one was wrong.
Yes, it was. Should have 2,000. It should have been a 1,000. This is why we double check our stuff, because this is telling me, okay,
That
something's
would
not right.
mean the third one would be 0 then? The third
No, good.
S subtract 15.
It'd be 15.
But we don't have, so 15 is half, but all of these sides are less than half, less than 15. So you're gonna get a number in there.
Yeah. It's gonna be a positive
So
number.
you're
It might be
gonna
a
have-
small one.
The square root of
Okay, just make it more.
15 times 15 minus 5, which is
Still got it
10,
It's 100.
times
The
15
answer
minus 13 is
238.
2, 15 minus 12 is 3. This you should be able to do a little bit easier.
Okay, wait. 1 sec. So we got 15. And then we got.
10 times 2
Okay.
times 3.
Oh, it's half everything.
Half every time, yes.
So then
So S is
15.
1/2 perimeter.
Minus 12.
I thought that's not making sense, it should be at least close.
Minus 13. Yeah, you get 10. 3, 2. Yeah, we got 30. We got 30 now.
Ah!
Yes.
We should be getting 30.
15 minus 0.
Okay, that makes more sense.
15
that one triangle to get that altitude. You don't know that, so then you would have to go ahead and you could use Heron's formula or Heron's formula, okay? So that is another way of getting it. To me, it's a lot more work. Notice how much longer it took you to do that. A lot more work. So if you have the base and the altitude, don't work with this, okay? Okay, the next things we're going into, I'll see if anybody remembers. The formulas for any of these is we are going into the area of a parallelogram and the area of a trapezoid. Anybody remember the formulas for either of those? It's not something I had you watch or anything. I'm just asking from previous classes. Does anybody, let me give you a picture of a parallelogram.
Is it though you just make those into 3 sections, 2 triangles, and then the rectangle?
You could do that. That is one way of splitting it into triangles and then making it into the rectangle in the middle. That's one way of doing it. But there is actually a formula for getting the area of a trapezoid. And let me give you a hint.
You use the parallelograms.
A parallelogram, sorry. If I take that, cut it off, and move it down here, what will I have?
A rectangle.
A rectangle. Do you see how if I cut off this triangle, because it's a parallelogram, I can move it down here. I know my drawings are not perfect, but I can move it down here, and it will give you this rectangle. What is the length? So it's a rectangle. What is the length times the width of my new rectangle here? What can you tell me about it? How long is the base?
The same.
It's the same. The base, because notice all I did was cut this portion off and I added that same portion over here. So my base is the same as the base of the trapezoid. I mean a parallelogram, sorry. Okay. What is my width in this case? This distance right here. What is that? What would you call it? Yes.
The height.
It's the height, because it forms a right angle right there. So it is the height of that. So it's really the base times the height. Do I have to divide it by 2? That's not what I wanted. Do I have to divide that by 2? Or do I have a full rectangle? No, all I do is really square up my parallelogram by taking one end and putting it over here and getting a rectangle, and then I just have to use the formula for a rectangle because that's what you have. Okay, so if you need to see that, draw it like that so you can see, oh, I cut this off and I put it here. So the base did not change. The height is what I'm looking for then, so I can finish it out. But I've made a rectangle that's now the base times the height, straight up, the straight up height for that. Okay. So how do you find those amounts? Okay. There's some ways to. Oh no, that's not. That is in base and corresponding height. Yes. Okay, so it gives you a proof of why that's true. I don't really care if you know why it's true. Okay, so that's basically how you find it. You have to be able to find this height. Again, that's not so easily done.
get that angle, and then you'd have to find this, but
Yes, it gets much more confusing when you start doing that. Okay, this formula is so much easier. The trick is finding that height. Okay, and sometimes they'll give you what that height is, and sometimes they won't. Sometimes they'll give you the length so you can find the height. Okay, and so really, you really have to know what you're looking at to find those. Okay. Now, a trapezoid looks different.
I'm gonna give you this one for right now.
This trapezoid is actually pretty easy to do because if you look at it, you've got a triangle and a rectangle, correct? So we could take just the triangle times the rectangle, the triangle area, and add it to the rectangle area. Okay. So in a trapezoid, we need to know what this length is. This is called base 1. So in the trapezoid, we actually have two bases. They are the two parallel sides. Okay, so there are two bases, which are the parallel sides. It doesn't matter which one you call base 1 and which one you call base 2. Okay, doesn't matter. Base 2 is this entire length here. Base 2. Okay. This is the same as this in this one, so it's the height. But if we don't have a height, then we have to find it differently. Okay. So in this case, what you're doing is first you're going to find the area of base 1 times the height, because that's my rectangle. Does everybody agree with that? That's the amount of the rectangle. Okay. I'm going to add that to this triangle, which we know its base is actually base 1 or base 2 minus base 1. Does everybody see that? The base of this is if I take base 2 and minus base 1, that's what this is. And you took base 2, the whole thing, subtracted out this, and I end up with this amount here. Times the height, but it's a triangle, so we're going to do it by 2. Okay. That is your triangle. I'm using algebra to show you something here. Okay, so this is your rectangle that we found here. It's base 1 plus times the height. This is my triangle. The size of this side is base 2 minus base 1 times the height divided by 2. Now, using some algebra, here's where our advanced algebra comes into play. We are going to put these two together and see if we can come up with a formula. Okay, so I'm going to erase this so we have a little bit more room. Okay, so we have base 1 times height plus base 2 minus base 1 times the height over 2. Does everybody agree with that? I just rewrote that. Okay. So we're going to combine these. Notice it's addition. So what do I have to do before I can add those two terms? Nobody knows? One's a whole number, one's a fraction. What do I have to do before I can add this no fraction. This is a fraction. I want to add two fractions. I must get a common denominator to add two fractions. That is just part of algebra. You need to know how to do that. Okay, so I want to get a 2 on the bottom. So I have to multiply this by 2 over 2. So it gives me 2b1h over 2 plus, and I'm going to distribute this while I'm doing this just because I don't want to do the next step. I'm going to go ahead and distribute h through these. Does that make sense there? Take h times b2, h times b1, so I'm just distributing algebraic stuff, all algebraic stuff, over 2. So I have b2h minus b1h all over 2. Okay, all I did was on this one, I multiplied the top and bottom by 2. On this one, I distributed the h through the parentheses. Now, when you add fractions, we only add numerators. So my bottom number is going to be 2. On the top, I'm going to have 2b1h plus b2h minus, no, that wasn't 2. That was just bh2, minus b1h. That was kind of lousy writing. 2bh1 plus b2h minus b1h. This is where the algebra definitely comes in. Okay. Reviewing algebra with just variables. Okay. If I look at this, I have 2bh1 minus 1bh1. You see that? 2bh1 times minus 1bh1. b1h. b1h, sorry. 2b1h minus 1b1h, which gives me 1b1h, correct? So this simplifies down to b1h plus, that canceled those two, plus b2h all over 2. That's not quite the exact formula we see for trapezoids, but we can pull it out. I'm going to factor out an h. Okay. I'm going to factor out an h. If I pull the h out, I come out with h b1 plus b2, oops, it's not an absolute value, that's a parentheses, over 2. I don't have to have this over 2. It's going to do the same thing, because if I multiply these two and then divide by 2, and what it ends up being is you are actually taking the average of the two bases, and that's going to be the length of your width. Okay, that's going to be the length of your rectangle, and then you're multiplying it by that. So this really ends up being, this part is the average of the two bases. So if you were to look, I'm going to just draw some sort of trapezoid here. Okay. If I were to look, so here's that. But here is the length of these two bases. And if I took the average, which is kind of there, and right about there, that's the rectangle that we are actually coming up with, and that we are finding, and that's the rectangle we're finding the area of. And if you looked at these closely, the way they should have been driven, this would equal this, and this would equal this. Now, it may not look like that right now, but it does. They equal each other. All of these, the ones inside here would equal the ones that we don't have in here. You could cut those off and put them, and you would get that size of a rectangle. So we really measure everything in terms of rectangles. If you notice, everything we've done today is we took a triangle, made it a rectangle, and cut it in half. We took a parallelogram. We made it a rectangle by moving it over and shifting it over, cutting the triangle off and putting it on the other side, and we got the area for a parallelogram. We took a trapezoid and we had to average the two bases to get the size of the rectangle that we're going to make. So really, everything we do in geometry with areas on these types of things is all doing rectangles. Okay? All four-sided figures can be found by making them into rectangles. Every one of a four-sided figure can be made by doing that. Okay? Not all things, the basic unit of geometry is all polygons can be made or found their area by using triangles. Okay? So all things that are polygons can be measured, the area can be measured by using triangles. But a triangle is part of a rectangle. So really it's all back to rectangles again. Okay? So that's the key to most of this. Okay? So I'm going to go ahead and give you a break. You're going to then have some assignments from 9.1 through 9.4. Please, anyone that has not joined the Google Classroom, if you have a phone, try to click on and get into the new Google Classrooms, because that's where I'm going to put new assignments. Okay, I sent you the link that is in Teacher Ease, your email that's in Teacher Ease, that's where the link is. My first email did not have the link in it. My second one that says one more try, that's the one that has the link in it. So go ahead, take a nice break. Yes? Oh, I thought you were talking to me.
Is that like the most crushing? Yep. Okay. That is like a mouse. Yes. Yeah, I didn't realize that. Yeah.